Hi everyone, welcome to my channel. My name is Fikret. In this end-to-end course, we're gonna dive into amazing world of real-time analytics in Databricks. I'm excited to take you there. Let's talk about joins. The syntax for streaming joins are very much like batch joins. However, there are a few important considerations that you need to be aware of when building streaming joins. First of all, let's differentiate different types of streams. So you can join streaming data frame to static data frame. So this is probably simplest form of join. One important consideration is caching. So make sure that you are caching static data frame because that can significantly improve the performance of your join. As to joining stream to stream, you have to differentiate between inner joins and outer joins. The watermarking that we have been talking about earlier applies to joins as well, because joins are stateful transformations. However, for inner joins, watermarking is not required, whereas for outer joins, you need to provide watermarking for both queries. Another thing to know when you're joining streams is, besides providing precise matching, you can also provide interval matching condition. We're going to explore this shortly. Let's start stream join exploration with stream to static joins. In command 65, I create two data frames. The first one is reading from office data and creates static data frame, whereas the second one creates streaming data frame. Notice that I have cached the static data frame in this case. And in command 66, I join streaming data to static data. So let's take a look at the results. Now let's take a look at stream to stream joins. So in command 70, I display weather forecast streaming data. So this data is generated on hourly base. However, notice that it starts at the 5th second of each hour. So I have deliberately introduced some shift to demonstrate joins with approximate conditions. My IoT measurement data, on the other hand, does not have that shift. So let's see what happens if I try to use precise join matching when I try to join these two streams. So in command 71, I'm joining these two streams using common columns like city and event time. And as you can see, my stream does not produce any rows. Now let's take a look at modified version of this code. In command 72, I have similar join, except I am using interval matching condition for event time column. So you can see that in lines 6 and 7, I provide a precise matching for city column. However, for time column, I say my event time from IoT side needs to be within 15 seconds of range of weather forecast event time. Let's run this command and take a look at the results. As you can see, now I get the results from both data frames. One thing to notice here is that I did not provide watermarking clause from neither data frame because it's not required for inner joins. However, it's best practice that you allocate some watermarking window because data may come with delay from both sides, and if that happens, unless you provide watermarking window, you may get mismatches. Now let's take a look at watermarking example. In command 74, I have similar weather streaming data frame. However, in this case, I have allocated 20 seconds watermarking window. Similarly, I have provided a watermarking window for my IoT measurement stream. Now I can join these two streams using left outer joins. Now, because in command 75 I am using precise matching, and because we have outer join in place, I've got the results. However, the results only represents my IoT measurement data. Any columns related to weather forecasts are empty. In command 76, I have modified my matching condition to interval matching, and now I get results from both sides.